Welcome back to Project Pulse. In the previous lesson, we calculated the unlevered pre-tax project IRR, so the return of the asset before any financing and before taxes. To move from pre-tax to after-tax returns, we now need to model depreciation and amortization, because they drive taxable income and therefore tax payments. That's exactly what we'll do in this lesson. And once depreciation is in place, we'll be able to model the unlevered after-tax project IRR. If you're new to this Deal Lab series, I recommend starting with part 1, where you can download the model start file for free and build the model alongside me. Link is in the video description below. Before we get to the modeling part for this lesson, let's briefly cover some background for depreciation and amortization. First, depreciation. It spreads the cost of tangible assets, like equipment and infrastructure, across their useful life. It's a non-cash expense, but it reduces taxable income, which is why it matters for after-tax cash flows. And second, amortization. Same concept, but for intangible assets, like software or development rights. And again, non-cash expense, but it affects taxable income and therefore the project's tax profile. And third, MACRS. MACRS is the tax depreciation system in the United States that defines standard recovery periods, like 5, 15, and 20-year classes, and front-loads deductions into earlier years. Mechanically, we apply a MACRS percentage schedule to the tax basis each year, often with a half-year convention, and that produces the annual tax depreciation we will use in the model. Now let's connect the concept to our case study inputs. This page of the information memorandum specifies the tax depreciation treatment for each CapEx line item. In Project Pulse, we keep it simple. We only use 5-year, 15-year, and 20-year MACRS. And those assumptions will drive the yearly percentage schedules we will pull into the model. Now let's move back to the checkpoint file from the previous lesson. You can see those same assumptions implemented here on the inputs time independent sheet, as drop-down selections by CapEx category. So the IM tells us the rule, and in the inputs time independent sheet is where we store that rule in a structured way that the model can pick up consistently across cases. Next, on the inputs time dependent sheet, the drop-down selection is translated into an actual year-by-year percentage schedule. If you're modeling a US project, MACRS tables are publicly available. You can look them up online and paste the schedule into your model exactly like we've done here. And if you're not working with a US tax regime, you will often use straight-line depreciation instead. And the model also supports that alternative as a clean plug-and-play option. Alright, now let's actually move to the operations sheet and implement our depreciation and amortization section. And that is from row 405 and onwards. And the first thing we will focus on is actually pulling in all our percentage schedules from our inputs time dependent sheet. So we will pull in these time series values into our operations sheet. And we will do this 3 times because initially we have different capital expenditures that are required to actually build the battery project. And then we have 2 different augmentations scheduled, which means we have a CapEx outflow sometime during the actual operations of the project. And for that purpose, we will have to reset these time series values so that they actually kick in when the augmentation actually occurs. But now let's start with the initial CapEx. And what we'll do is have a year counter right here. And that is going to be simply equal to our previous period, which is this empty cell right here. Let's actually put that in parentheses. So open parentheses, our previous period plus 1, close parentheses, and we'll multiply this with our project lifetime flag or with our operations flag. So let's multiply this with K12. And depreciation typically only kicks in once COD has occurred, which is also the reason why we multiply here with our operations flag. Hit enter. And let's drag this over, Control R. And here you can see that we now have a different year counter for each single year. And that will now allow us to pick up these MACRS and straight line tables from our inputs time dependent sheet, which also count a year from year 1 onwards. And to do this, we will use a SUMIF function. So type SUMIF, and the range is going to be in our inputs time dependent sheet. And this is going to be our year right here. So from L128 all the way to AF128. We hit F4 once to fully anchor this range. Then comma, for our criteria, we go back to the operations sheet. And the criteria is the year we are in, which is here in K408. And we'll only anchor this to our row, so hit F4 2 times, comma, and the sum range or the return value is back in our inputs time dependent sheet. And that is going to be our first row here. So select all of these guys up until AF129. And here we hit F4 2, 3 times because we only want it anchored to the column, but we want this reference to start moving down as we drag the formula down. Close parentheses, hit enter. Copy this and paste it here. Let's see if we got the anchoring right, and we can drag it over, Control R. You can see our 5-year MACRS schedule kicks in during year 1 to 6, and that is because of our half-year convention. You can see that the first 2 years we have a significantly higher depreciation assumption than in the last years. And same goes for 15 years MACRS and 20 years MACRS. You can see how the depreciation percentage slowly degrades over time. And then we also have straight line depreciation assumptions, which is basically just a flat assumption for say 5, 15 or 20 years. And these are the time series values we will need for our initial CapEx. And now we need to do the same exercise for our 2 augmentations. So let's start with augmentation 1. And here we will have our year counter as well, which is going to equal to, let's scroll up to our first augmentation. And in row 71, you can see that we already have a augmentation 1 year counter. So all we have to do is simply link it to this value here, hit enter, drag this over, Control R, and this essentially starts kicking in once the augmentation has occurred, which means we from then onwards want to reset our depreciation time series and want to pull in the actual time series values once the augmentation has occurred. So let's see if we can simply pick up this formula up here, hit Control C and Control V, F2, and the reference to our inputs time dependent sheet should be right. The only thing we'll have to do is drag this reference down here, hit Control D, drag it out all over, Control R, and let's see what's wrong here. So let's check the references. So here we actually move down the row. So what should happen is we start here with 129. So all we have to do is adjust this to 129 instead of 139. Hit Control D again, drag it over, Control R, and now we should get the proper values. And you can see for our augmentation 1, the depreciation percentage now kicks in once the augmentation actually occurs from an energetic and CapEx standpoint, which will simplify modeling the depreciation further down here very much. And you can see that if we change cases to a different case where augmentation might occur earlier or later, let's select case 1, these values here will shift accordingly. And apparently we get an error in our previous modeling section in row 380. So let's see what happened here. And you can see we actually divide by 0 here. So let's fix that error from a previous lesson. And we can simply do this by wrapping these 2 formulas by an if error statement. And say if error, this should be 0. Same for this one. If error, then this should be 0. Drag this over, Control R, so that we make sure that our MMRA contributions are actually not returning an error, because before we have divided by 0 right here if a second augmentation hasn't actually taken place, which would be the case for case 1. So make sure that you fix this error, and then it's moved back down. And you can see, depending on the case selection we have up here, we shift our depreciation percentages as well. So let's pick up all of these guys here, hit Control C and Control V, and then we'll have to adjust some references. So first we do the year counter for the second augmentation. And that is actually in row 79 and not 80. Make sure you adjust this one. And then for this one, hit F2. We start again in row 129. Let's double check this, but I believe it was 129. Yes, here was 129 as well. So drag this one down, hit Control D, grab all of these guys, drag them over, Control R. And now the only thing we will have to adjust is the reference, which is currently still picking up the augmentation 1 year counter. So drag this down again, Control D and Control R. And now these percentages kick in once the second augmentation has actually taken place. Great, and that means we can now already calculate our depreciation and amortization, which will reduce our taxable income. So what you can see here in column G, we already pull in our taxable basis. So for instance, for our battery packs, cells, racks, and containers, as well as the battery management system, we pay $42.4 million upfront. And the issue here is that if we actually would expense that within the same year, then we would have a massive loss in that year, wouldn't pay any taxes, and just significantly build up our tax loss carry forward account. And to avoid this, we will actually spread out these costs over a 5-year term. And we can do this by using a SUMIF function again. And since we want the depreciation expense to be displayed negative, we will start with a minus SUMIF. For our range for the SUMIF function, we will select these guys here. So D409 to D414, which is our depreciation selection. Hit F4 once, comma. The criteria we have right here in column H, so select H436. This is what we have selected via dropdown in our inputs time independent sheet, and that is being pulled into the operations sheet. Hit F4 1, 2, 3 times so that it's anchored to the column, but can move down rows as we drag the formula down. And then the return value should be up here, our percentage. And here we hit F4 1, 2 times to only anchor to the rows. Close parentheses. And with this formula, we basically pull in our relevant percentage, which for instance, in our case is 20% in year 1 after COD. But then we also have to multiply this percentage with our tax basis, which is here in G436. And we anchor this 1, 2, 3 times only to the column. Hit enter. Let's drag this all the way down to our transaction costs, but let's not do it for our 2 augmentations yet, because as you can imagine, these formulas will have to be slightly adjusted so that they actually pick up the values for these 2 time series events here. Hit Control D, drag it over, Control R, and you can see that we now spread out these costs, for instance for the batteries, over a period of 6 years, because we apply a half-year convention assumption, so that essentially the 42.4 million will reduce our taxable income over a period of 6 years instead of just expensing it in year 1. Then we have for our transformers an assumption over 15 years. And for our interconnection and metering, our depreciation assumption is 20 years. And since it's 20-year MACRS on a half-year convention basis, what happens is that we cannot fully depreciate the asset over the actual operating lifetime, because for a half-year convention, 20-year MACRS would actually require 21 years of operation, which is the reason why we are missing some depreciation expense in the very last year, which would be year 21. So if you go back to the inputs time dependent sheet, you can see that for year 21, we would still have 2.2% left. But since we won't have any operating income to offset that depreciation amount against, we're gonna lose a slight amount right here, just in case you wonder why these two numbers won't match. Then we can move on and do the same exercise for our augmentation expenses. And this is the same logic, so let's just hit Control D, hit F2, and then let's amend the actual references accordingly. And here we'll refer to these labels right here, and we want to return these values from row 419 to 424. The other two references are still correct. Then let's copy this, paste it special here, Alt-HVSF, so we don't mess up our formatting. Hit F2, and let's do the same thing for the second augmentation. Drag these two references down, hit Enter, and let's drag this over, Control R. And you can see that for our augmentation 1 and 2, we now have depreciation expenses right after the augmentation has taken place for a period of 6 years each. And for the second augmentation, we actually lose the last year again, which is why this depreciation expense is slightly lower than our tax basis. All right, and then the only thing we'll have to do is take the sum of all of these depreciation and amortization expenses and drag this over, Control R. And let's actually start doing this from column K. So let's do this again, sum of this, drag it all the way over, Control R. And now you can see that our actual depreciation and amortization expense is $136.5 million US, out of which roughly $114 million are from initial CapEx and 22 million are from our augmentation 1 and 2. Great, we have now implemented the full depreciation and amortization section. And in the next lesson, we will use this to calculate our unlevered taxes, and that will allow us to move from unlevered pre-tax IRR to the unlevered after-tax project IRR. Great guys, this was it for this lesson, and I will see you in the next lesson. See you there.